Our grand challenge for this project is to manage the nitrogen cycle. We chose to focus on lunar-based controlled ecological life support systems, which is often abbreviated to this. Basically, we want to design a greenhouse that'll produce some food, recycle that water, and replenish our life-giving oxygen. The things we want our design to mitigate are waste and poison. Namely, we don't want to lose water, we don't want to lose nutrients, and we don't want nitrates in our drinking water, and we don't want fixed nitrogen gases in our breathing air. So with that in mind, we came up with the following criteria. We want to optimize nitrogen uptake by the crops. We want to optimize the weight of material needed from the earth. We want to feed as many people as cheaply as possible. And we want to optimize replenishment, so we don't want to be shipping out more food and fertilizer from the earth. And since we are recycling water, how we handle organic waste is going to be pretty important. We want to watch for toxicity here, as well as our agricultural emissions. Here, finally, is the actual design. Big picture, it's a hydroponic co-culture, meaning there's no soil involved, it's all water. And we have rice and shrimp produced at the top, with wheat downstream of that, and kale downstream of that. At the bottom, the water from the stream joins a stream of wastewater from the colony. It's pumped to the top after passing through a filter to remove any bulk waste from the colony water. We chose shrimp for the aquaculture because they can eat dead and decaying matter, as well as kale, which we're also growing. The shrimp will provide an important source of protein for the colony. Air coming out of the top of the greenhouse will be enriched in oxygen, which can be circulated throughout the rest of the colony, and potable water can be collected from the water evaporating from the system. As for scale, Schwarzkopf in 1991 estimated that about 32 square meters of plant growing area is needed to meet one person's water and food needs. So for a colony of about 1,000 people, that's 32,000 square meters. So to accomplish that, we're going to have to layer these very close together, and we're going to have many, many stacks, and we'll have a very large greenhouse. For nitrogen lost, there is no nitrogen lost through the water, as the water collected is going to be through the evapotranspiration. The only nitrogen that would escape the system is through the air feeding into the rest of the colony. So I'm going to give that 4 out of 5. For weight, most of the system can be made using lightweight plastics, and the pump is going to be the heaviest thing, so I'm going to give that a 3 out of 5. For crop yield, the fact that it's not purely vegetarian is going to hurt the yield overall and the efficiency, so I'm going to give that a 3 out of 5. Since there is no soil involved and the growth medium is going to be the water that's continually recycled, I'm going to give that a 5 out of 5 for soil sustainability. And for safety, I'm also going to give that a 5 out of 5 for not poisoning the water.